Okay, let's start. So last two lectures, we were only talking about networking. Today is the last lecture of the networking, where we will talk about the top layer of this TCP/IP model, which is called application layer. So application layer has many protocols. For example, let's say we have SMTP. For example, SMTP stands for Simple Mail Transfer Protocol. Actually, whenever you send an email, the emails usually use this protocol, SMTP. And there are many other protocols for mail as well. And then, for example, we have FTP protocol, which stands for File Transfer Protocol. Then, we have a lot of protocols on the application layers. This transport network and network access layers, they are fixed. We don't have many protocols on those low-level layers. For example, in transport layer, we have only TCP and UDP. We have some new protocols that they have invented in the last few years, but we don't really talk about them so much. But mainly when you talk about transport layer, we only have TCP and UDP protocols. And we talk about network layer, we talk about IP protocol. And when we talk about this physical layer, we have Ethernet protocol. And you learned that each protocol has specific format that we call them a frame or a packet. For example, this was an Ethernet frame. This has this very specific exact format that sender side and receiver side, they both know what this format means, and they both understand this. For example, we talked about IP protocol, and we had an IP packet. IP packet also has this specific format. And we went one level up when we talked about TCP and UDP protocols. So TCP and UDP protocols also had a frame that we showed last lecture, that both of the sides in the network, they understand. As addressing what we had on this bottom layer, what we used as address, just a question. What was the physical address that we used on this network access layer? For example, what's this destination address and source address in Ethernet frame? Actually,
it's MAC address.
Yes, MAC address.
The laptop. Yeah.
Yes. MAC address, which was device specific. It is bound to your hardware. Then we had in the network layer, as it is very obvious, we have IP addresses. This is usually used by routers. For example, when people talk about routers, they say that routers are layer 2 protocols, and no, layer 2 devices, because they actually, when a router receives a packet, it inspects this first layer and then it looks at this network layer, but it doesn't look at the rest of the layers, because routers are usually concerned about IP addresses, not, I don't know, port, not about, I don't know, pass, URL, etc. But routers usually just only look at IP addresses. That's why they call them layer 2 devices. Okay. So today we will talk about application layer protocols. Application layer protocols, the most important and the most famous one is HTTP, which we briefly talked about last lecture, which HTTP stands for Hypertext Transfer Protocol. So HTTP stands for Hypertext Transfer Protocol, and initially it was designed to just transfer text between the networks. And hypertext just means that it is a text which has links inside it. For example, when you visit a website, let's go to this website, for example, we have this website, and this website has some links. That's why they call it hypertext. This is just a text, formatted text, and that has some links inside. Okay, so HTTP request was initially designed, was created to transfer texts among the network, these hypertexts. We will talk about HTML next week. Probably we will have a break. After then, we will have some lectures. Okay, so let's quickly look at HTTP protocol and what properties an HTTP protocol has. Unlike the other protocols, for example, this Ethernet protocol, we only talk about bytes. For example, from 0th byte to the 7th byte, we have preamble. Then, for example, from the 8th byte, from the 14th byte, we have this destination address, etc. On the IP packet as well, we were only talking about bytes. But HTTP protocol is actually a plain text protocol. We only have text in HTTP. At least one, the HTTP version 1.1, we only have texts. So what we have in HTTP protocol, we have verbs. Verbs, for example, we have get, post, put, delete. These are some HTTP verbs. Then we have a pass. Then we have headers. We will talk about them. We will talk about all of them. Then we have step, like request and response. Then we have, I don't know, request body. Then we have response body. Okay. Okay, so this is some properties of HTTP protocol. Before going to this, because we need to know what a pass means, we need to look at a URL. Okay, URL. I'm sure that all of you have seen a URL before, but let's anatomy of a URL. Let's look at this. Okay, let's open this image. Maybe this image. Copy it and paste it here. So all of you have seen a URL. URL stands for Unified Resource Locator. Okay, this means whenever you look for a resource on the internet, you need a URL, because URL stands for like Unified Resource Locator. If you want to locate that resource, you need a URL. And URL has some parts that is common for every URL. For example, just some websites URL looks like this. For example, https:// the www.example.com. Then we have colon, we have port number, then we have slash, then some blog article search, then we have question mark, etc. Okay, let's look at the parts. So always before this colon and // we always have a protocol. We are on the application layer. Which protocol are we using? Are we using HTTP? Are we using HTTPS? Are we using FTP? Are we using, I don't know, file protocol? Like, there are a lot of protocols on the application layer. And on the URL, we only talk about application layer protocols. For example, on this specific URL, this protocol is HTTPS. I will just briefly talk about the difference between HTTP and HTTPS. But just for now, let's assume that this is HTTP. Okay. Then we have a. Then let's actually, this part, we can look at this part as a whole. This part is a domain or host name, whatever you can call it. You can call it domain or host name. Okay, domain or host name. This part of the URL between this protocol and this colon, like between this / and between this colon, this is called the host name or domain. For example, facebook.com, this is a host name or domain. This can also be an IP address. And you can, I don't know, let's look at Facebook's IP address, ping facebook.com. Let's stop it. For example, this is also a URL. URL also can be like this, for example, HTTP. This is also a URL. This doesn't have to be a domain name. This can also be a IP address. Usually people can't remember IP addresses. We will also talk about them because we are not good at remembering all the IP addresses in our mind. People like the engineers of the internet, they created something called domain name or host name. This is just a plain text that everyone can remember. For example, let's say you build a website and you don't want your user just to remember your address. You want your users to remember your website's name, domain name. Okay. So after the domain name, we have a colon and we have a port number. Like as we talked, this domain can also be an IP address. IP address defines a device, not an application. Okay, it defines a device, for example, my laptop. But inside my laptop, there might be several applications. I might have one Python application, one Java application, one Chrome, I don't know, Zoom, a lot of applications in my device. So but that's why this port number here is necessary. After IP address or the domain or the host name, we should have a colon and a port number. Okay. Do you have any questions until this part? Okay. Then after the port number, we have a slash and then some pass. We call this part a pass. Okay. Some people call it pass or pass name. It's the same. Just anything that comes after this slash after port number, this is called a pass. Pass usually defines a folder or something inside my laptop, inside any server. For example, the server is also a device, a computer. This pass defines a let's say, for example, they have this web server. Inside blog folder, inside article folder, inside search folder, they have something, and requesting this URL means that I want that whatever in this folder, I want that resource. This might be an image, this might be an HTML document, whatever. Okay. After pass finishes, we have a question mark, which defines that after the question mark, we have some parameters. For example, when we wrote functions in Python, functions had some parameters, right? Let's look at some functions from our. For example, you see we have a function which is called find min index. We pass array and start index as parameter. This might be I can pass any array and any start index, doesn't matter. I can call this function, okay? And just like that, we have a query string, or some people call it query string, or some people call it just query parameters. This is just parameters that you send along with your request, okay? For example, let's say I am requesting an image from some web server. I want this image to be, for example, 500 pixels wide and I don't know, 500 pixel tall. I will pass my parameters to this like this, for example. Now, these parameters like these are everywhere. For example, whenever I go to YouTube, I watch a video Yeah, we have secret invasion. Okay, for example, let me paste this YouTube URL here. For example, in YouTube, we have this HTTPS protocol. After colon and slash slash, we have host name. This whole thing is the host name. Then we have this pass, which is called watch. Then we have question mark. After the question mark, we have a parameter. Name of the parameter is v, and the value of the parameter is this long random string, which is just defines the this is just ID of the video, like which video I want to watch. Okay, now I say I'm watching a video, but I need to define which video I am watching. Okay. Okay, for example, in this example, for example, probably this is a blog website. For example, they look for an article which has ID of 720, and they want this in English. That's why they have another parameter which is called HL. I don't know what it stands for. H and L stands for language, probably. H stands for something else. These all are customizable. Like these are not fixed. Any application, like you visit a lot of websites during your daily life, then all of these websites have different URL parameters. They have different paths. They have different domain names. So it doesn't mean that like this doc ID should always be there. I don't know, this blog should always be there. It doesn't mean that. This means that we are just defining the parts of a URL. We are just looking at the anatomy of URL. Okay, now let's look at another image, anatomy of a URL. Let's look at another image. For example, this image, what we have here, this also uses HTTPS protocol. Then we have this domain stuff, video.google.stuff, blah, blah, blah. Then we have colon port. Then we have pass, which is called video play. Then we have a parameter, which is called doc ID, which is this long number. And then we have and sign, and we have another parameter, okay? You might encounter a lot of like such URLs. This is very low quality. Okay, for example, this one, we have a protocol, then we have colon slash slash, we have host name or domain name, then we have colon port, then we have, for example, in this example, the pass is only slash. Okay, in the previous example, we had pass like slash blog slash article slash search. This is just a slash. Slash also a pass. Slash is also a pass. For example, whenever you visit facebook.com, you actually visit at the slash URL. Okay, it doesn't writing this one doesn't mean that we don't have like this slash. This is a pass name. Okay, you may have something else here, but the slash means that this itself is a pass name. Okay. And then we have another parameters here as well. For example, this parameter is called Q, and its value is app engine. Okay. In this example, we had parameters called doc ID and HL. Doc ID is this number, and HL is English. We also have a fragment. This is not necessary right now. Like this is not very common to use. You might see them whenever you go to a website, but like this is not really necessary. Okay. Do you have any questions regarding to a URL? Okay. So this is the anatomy of a URL. So let's say I am visiting facebook.com. Okay. To visit facebook.com, Facebook has an HTTP server on their devices. Okay. HTTP server means that this is a server. It means it's a computer that this understands HTTP protocol. We call the device server because it serves us some data. For example, I write comment, it I don't know, gets my comment, stores some database, shows it to other users. It serves me some data. It serves my requests, right? That's why we call it server. Last lecture we a little bit talked about client and server. For example, we also wrote small chat application using Python, which was UDP client and UDP server. For example, UDP client and UDP server means that we have two applications that both understand UDP protocol. And HTTP client and HTTP server means that we have an application that understands HTTP protocol. They both understand the HTTP protocol and they both communicate via HTTP protocol. Okay, so this is it. So we have what? We understand the URL, hopefully, then we can switch to the HTTP. So whenever I visit a website, let's say I visit a facebook.com, I make an HTTP request. It means that I'm asking, request just means for I'm asking for something, and server needs to send me a response. Let's say I'm a client. Okay, I am a client here. Okay, I'm a client. We have a server here. This is a server. I sent, if I want to, in server, the server is just a device, right? It has some image files. For example, let's say the server has some image. It has a file. It has, I don't know, contract.pdf. I don't know. It has some avatar.png. It has a lot of files and folders. I don't know. Okay. Let's say it has image folder. Okay. Inside image, they have avatar PNG and I don't know, whatever PNG. Okay, let's say this is the folder structure inside our server. And this is the server and I am the client. I want to request this avatar.png from the server. This server is, let's just assume that this is an HTTP server. Okay. And I am an HTTP client. Okay. This I'm just HTTP client. And the reason why I write this protocol name here, it means that just we both understand this HTTP protocol. Okay. Whenever I want to request something from the server, I sent it a HTTP request. Okay, I sent an HTTP request. And this is what an HTTP request looks like. Let's just remove this people from here. Okay, and this is what an HTTP protocol looks like. So I say I want to get, okay, I want to get something. We talked about verbs. Verbs define that verbs are just like in English, they are verbs. Like you just say what you want to do. For example, I want to say that I want to get a resource. Okay. So as I told, I want to get this image/avatar.png. I need to specify the path name to that image. What's the path name to that image? The slash means root of the server. For example, root directory of server is this directory, let's say. And I want image folder and this avatar.png. Okay, that's why slash is root. Then I have image folder / I have avatar.png. Okay, so this is my HTTP request. And actually, this is part of my HTTP request. Okay, so this is, I want to say the server that I want to get this image. Then I need to specify the version of the protocol, which because HTTP has many versions. The most common version of the HTTP is 1.1. I just say that client says that, okay, I am talking HTTP protocol version 1.1, and I want this file, this resource from you. And also, this client also needs to define some headers. Okay, what are headers? Like this is a verb, this is past name, and this is protocol version. Like we talked about, like we defined verb, we defined past name, and now we need to define headers. There is always one header that always needs to be defined. Like if you don't define that header name, it means that something is wrong. This header is called host name or host, I don't remember exactly. Let's say this HTTP server is called, I don't know, server.com. Okay, I just need to define this host name here. And this host name here, this is the exact host name that we talked about here. Okay, whenever you open your browser and write facebook.com, well, your browser, this Google Chrome, makes an HTTP request to Facebook's server, and it puts facebook.com here. Okay, let's say facebook.com, puts facebook.com here, and the rest of the URL, like which is the past name, this is the past name, rest of the URL is put inside this first line of the HTTP protocol. Okay. Then we might have a lot of headers, but it's not necessary for now. This is the very basic, very simple HTTP request that we are making. So I made an HTTP request to this server. The server received this request. As we talked about just now, HTTP is just plain text. We don't have bytes, bits, etc. It's just plain text. Server just receives this text and just reads this text, okay? Then sees that, okay, this is me, this is my server, my host name, and this whoever this person is, he wants avatar PNG, which is located inside image folder. And yes, I understand HTTP protocol version 1.1. For example, if client wants to talk HTTP version, I don't know, 3, but server doesn't understand HTTP version 3, they will have some miscommunication and the request will fail. Okay, they both need to talk the exact version of the protocol. Okay, whenever the server like receives the request and starts to process it, for example, server will go to this image folder and will find this avatar PNG, and then will respond with a HTTP request. Sorry, HTTP response. So request means you are requiring something. Response means just you send the response, basically. Okay. So a client makes request, server sends response. So what server does here, it just sends a response, and response will look like something like this. Okay, response will look like, let's say server finds this image inside its folders, okay, and it will send 200, then okay, then it will also send some HTTP version 1.1. I think this should be something like this, I don't remember. Okay, HTTP 1.1. Then it will also have some headers. For example, let's say content type. Content type is, for example, image PNG. Then it will have this data of the image. Okay, for example, what's this image? Image is just bunch of bytes, right? It will have this bytes all over here. I don't know. bunch of bytes, I don't know, some text encoded bytes, I don't know, just let's call it image data, okay? Just by like data of that image will be converted to text and will be sent it along with the response, okay? So this first line is just a response line which defines status code. This is called status code, okay? This is called status code, and this one is called status message. This one is called status message. And this is just a version of the protocol. Then we have, as request have some headers, response also have some headers. We call it request headers, and we call this response headers, okay? It's just headers. And as last lecture I told you, actually, for example, you go to some dönerkhana and you request for döner. This is actually, for example, this is actually the part where you request for döner. And this is the part that you request for additional, for example, soğan olmasın, mayonezi bol olsun, you request this small information inside the headers, okay? As the server will also have some response headers. For example, in this case, server just tells that the image I'm sending is in the format of PNG. Server just states that client needs to understand what type of image the server is sending. And for example, in dönerkhana example, we have whenever the guy who makes döner makes your meal ready, he will put some badge on this döner that mayonezi çoxdur, soğanı yoxdur, and then you will receive that döner and you will eat it. So we have this status code, we have this status message, then we have content, like we have some headers. I wrote just one header here, for example, and here I also wrote one header, but we can have a lot of headers. For example, let's say just for example, client, let's say this image is very large, and client and server wants to just compress that image. For example, whenever have you used zip or tar rar files? For example, you want to zip all the files. Have you used it? Let's just see an example. For example, I have this Zoom folder. Okay. Yes. Let me just as column. Okay, I have this what's gallery as icons. I have this Zoom folder. Let's look at this Zoom folder. It is 4 gigabytes. It takes 4 gigabytes on my disk, this Zoom folder, because it has a lot of recordings in it. I can compress it. Okay, all computers, you also have it on Windows. You can just right click on the folder. There will be something like compress or zip, I don't know. For example, in Mac, I can click compress. It will compress all the data in this folder and will create me a file, which is called a zip file. Then this will be actually more lightweight than the previous folder. For example, if the previous folder was 4 gigabytes, it will be, I don't know, 3 gigabytes or 2 gigabytes. This is what is compression about. Okay, websites can also do that. For example, let's say I want this image compressed. I will say that I accept encoding, for example, gzip. Gzip is a compression algorithm. Then, for example, a server will say that, okay, I compressed that image, content, I don't know, encoding thing is gzip, okay? In this case, they both understand that I requested for a compressed image, and server sent me a compressed image. whenever the client receives the image, client needs to uncompress it, like extract this image from inside the zip. Okay, let's just wait for it. I don't know why it takes so long, because it's a lot of devices. Okay, so actually whoever understands this HTTP protocol, it is either an HTTP client or an HTTP server. Okay, your browsers are actually HTTP clients, like Firefox, Google Chrome, I don't know, Brave, Safari, Samsung Internet Browser. There are many browsers. They are all just HTTP clients. Whenever you visit a website, they're just making HTTP requests to some HTTP server, and this HTTP server gets that response, processes that request, and just sends back a response to you, and this response is shown you by your browser. Is it compressed already? Okay, let's look at this zoom zip. For example, if I look at this info, this is actually again 4 gigabytes, because probably it couldn't compress it too much. Actually, from 4.8, this is now 4.2. It saved, I don't know, 600 megabytes, but it's not much for this, probably because of the compression algorithm that this Mac uses. But you get the idea, right? Compression just means that you compress it, and decompressing means that you open it again and get the files from it. Okay. Do you have any questions regarding to HTTP protocol? Like to this part? No? Okay. I'm stopping this meeting and I will start new meeting. Please connect again because we are already running out of time. Okay. Stop.